Hey, g'day, it's Prezzo. Welcome back to my workshop. Now I wanted to include those two little cartoons at the beginning of today's video. They were sent to me by my illustrator friend Tony Lurie. Now Tony loves to have a bit of a joke using previous episodes that I've done as his inspiration. And what he was referring to in those two cartoons was this tool here. Now this was sent to me by Tom Kitchen, also known as Sand Rammer. And it's a tool to help you to extract patterns from sand molds when you're doing casting. So you use this to tap the pattern all around, make it loose, and you can lift it out. So Tony, it's not a water divining tool and it's not a tuning fork, but that's the sort of thing that Tony loves to do. That's his sense of humour. So I thought I'd include those because a few people had asked if they can see some more of his work. Now, this is episode 5 today of making a pair of Art Deco inspired wall lights, and in this episode we need to make a single assembly out of 3 separate parts that I've made previous, and they will go on the top and the bottom of these Art Deco lamps. So let's have a look on the bench and have a closer look. These are the 3 parts we're going to be working with today. Now these 2 parts here are brass fabrications. These have been made from flat sheets of brass that have been silver soldered together. And this is a casting, a brass casting that I made in the previous episode. Now, all 3 of these parts need to go together to make a single assembly, and they're then attached to a rectangular frame which holds the light bulbs and also encases all of the glass to make this light. Now, my original plan was to screw that casting to that cap there, and that's what those 2 holes are for. And then that cap was going to get soft soldered to this plate here. And the slot in that plate was so I could get at those 2 screw holes. Now, soft soldering to me was fairly straightforward. It's quite an easy joint to make, and then that would mean that this was the only separate part that needed to be joined after electroplating. Now, my plan fell apart in the last 2 days when I was contacted by a viewer named Chris Locke. Now Chris lives quite close to me and he's an actual professional electroplater. Unlike me, I'm just an enthusiastic amateur. Now Chris worked with the RAAF working maintenance on F-111 aircraft, and as part of that maintenance they had to rebuild fuel systems for the aircraft, and they had to be plated in quite exotic materials like cadmium and chromium. Now Chris watched the last video and then he contacted me and said if I went ahead with this plan and soft soldered that together, I would have a great deal of difficulty in electroplating into that sharp corner around there. Now, electroplating is a bit like spray painting. You're actually drawing ions, metal ions, off 2 anodes in an electrolyte, and they're drawn to the part using an electric current. And what tends to happen is the ions are drawn to surfaces in different densities depending on the geometry of the part. Now I'm going to show you a diagram here. This demonstrates how the plating thickness can change depending on the geometry of the part and the positioning of the anodes. And it's also dictated by what's called the throwing power of the electrolyte that you're using. Now when Chris told me I'm likely to get failure of the electroplating in that corner there, I had to rethink the plan. So what I've decided to do now is I'm going to try to screw this part to that one. But there's a problem. I don't have anything on this part that I can actually screw to and put a thread into without it being visible. And also I've got nothing right in the center here that I can attach to either. However, I've come up with a plan, and I'm going to have to make another part to go in this one here, and cut some holes or slots in this part here, and then I can screw everything together. So we're going to work on this part here. We're going to get a pair of slots cut into this part here, and the slots will make this slightly adjustable so I can sort of play with it and get it all accurate before we do anything further. So let's go and do that now. Okay, because we're going to do 4 of these, I figured it was easier just to jig this up. I'll just use a parallel there to align the part with this corner of the vise here. I've centre found the slot, and I also use an edge finder to come in a correct distance from this back edge. So I've already sketched all this out on paper, so I know what the hole centres need to be. So I've zeroed my DRO on that position there, and then I can just swap out the parts, do them all. Right, there's the slots done, so now we need to make the bracket that goes on the underside of the cap. To make this work, what I need to do is put a strip of brass between those edges there, and that will have a pair of holes that are threaded, and they will line up with the slots we've already cut in that cap there. Now, the problem with this is that it's probably not strong enough to just simply butt join that between those vertical surfaces there. What I need to do is sort of put a right angle bend in that across the top, and another right angle bend down that side there. But this brass is 2 millimeters thick, and because of that you use up a certain amount of material in making the bend. So it can be quite difficult to calculate exactly where that bend needs to go. However, one solution is just simply to make your material much longer than you actually need it. Make one bend and then use a jig to position the second bend. So I'm going to put this in the vise, and I want to get that material so nice and parallel to the top of the jaws. I'm just going to bend this around with a soft mallet. After making that bend, you can see how the material hasn't really come up tight against the end of the vise jaw. If I was to try and hammer that hard enough to do that, I'm likely to break or crack this brass here. So I'm just going to leave it like that. But what we need to do now is work out where the second bend goes, and that has to be accurate. So having made that single bend now, what I've got here is a steel former. Now this has been machined to be that inside measurement less double the thickness of the stock. So I should be able to fit 2 pieces of that brass strip down inside there, plus a little bit of clearance. It doesn't bend as accurately as you might think. So what I can do now is put one of these rounded corners, this has been radiused off to match the radius on the inside of that bend there. So that'll fit in there like that, and then I can put the whole lot in the vise and make the second bend. So let's do that. And this sort of takes away a lot of the guesswork. And now you still have to tweak it a bit. You know, when I did this the first time, it was a little bit tight, so I just took a bit extra off the length of that former there just to account for, you know, a bit of spring back in it and so on. So let's try this. I'm just going to use the vise here to try to counteract that spring back that you get. Alright, let's see if it fits. Goes in there, it's a little bit tight, but we can adjust that later. So I'll get the others of these done, and then we're just going to trim this to length. We can sort of mark it off from that job there, cut off the excess and then flip it over. that fits, and just as a general rule, always leave your stock over length. You can always trim it back later. This is basically scrap, so I'm not bothered about wasting that long piece there. Right, that's still a bit tight, but I can adjust that on the belt sander. But you can see how that's going to work there. Now that will have a pair of threaded holes, and they will line up with the slots that we just put in that part there. And then when we turn that over, we can get at the screw heads and assemble all of that. Now this needs to be soft soldered in place, but I'll need to trim this. I want that surface there of the bracket to be slightly below this edge, so it will pull up really tight. I'll need to deburr that part, but I've just prepared one earlier, this one here. And when that goes in, the cut that I just made puts the top surface of that bracket there just 1/2 millimeter below this edge on the side of the cap there. So when I do the screws up, it will pull the edges of the cap in really tight against the top plate. So the little bracket we just made goes inside the part like that. I've scribed off on these two edges the appropriate measurement back from this edge here. And in order to keep that there, I'm just going to use this little fireproof third hand. So once I position that, it's unlikely to move. Okay, so I'm going to use a zinc chloride flux on this, and it's a good idea to put that on before you heat it. That'll keep the metal clean while it's heating up. We now need to think about how we're going to attach the casting to this cap here, and that means that we're going to have to put a brass plate in the bottom of the casting. Now in the last episode I CNC machined that little pocket there, and I've cut some brass plates that fit into that pocket, and these have been left a little bit too long. They need to be trimmed off, and then we'll transfer the holes from the cap onto that part there, and then we can also do the same thing. We can transfer the holes onto this little bracket here and get everything assembled. Okay, I need to center this little brass plate here on the width of that cap there, and the easiest way for me to do that is to measure the width of the brass plate and then zero your caliper at that point. It doesn't matter what that measurement is. Now measure the total width of the cap, and that dimension there, that 34.86, is double the offset that you need from one edge to the edge of the plate. So let's divide that by 2, but you first of all need to set your caliper back to 0 again. So let's do that, 34.86, 0 that, and we need to find half 34.86, which is 17.43. Okay, zero the caliper at that point, or lock the caliper I should say. Put the plate on there, and then with your caliper you can slide the part up to the end of your caliper, and that's centered now. So I'm going to clamp that in place, and then we can poke a drill bit through from the other side. Okay, so that's our location. When I turn that over to the other side, now I can poke a drill bit through and mark those centers. Okay, so because I blued that, I've got some marks on there now. And we're ready to go. All these holes are threaded 4BA, which is British Association. And the reason I'm using 4BA is they've got a very fine thread, so they're good for thin material like this, and you can buy them from Model Engineers suppliers, and there's a wide variety of very small fasteners that you can get from those suppliers. So in this case I'm using brass round head screws. Okay, I'm going to clean that up, get rid of the blue off that, and we'll solder that in place in the casting. Okay, that's called sweat soldering. So I just applied the solder to the casting first, got it hot, put the part in, reheat it, and the solder will flow and join both parts. Alrighty, that's done. Let's get that attached to the cap. Okay, so that's a complete assembly now, and like I say, that's going to be much easier to electroplate as separate parts. And what we need to do now is get the holes drilled through from these slots into the bracket underneath here. So I just put some black marker pen on that bracket there so I can see where the holes need to go. And when I assemble the plate on top of that, I've got to account for the width of this brass angle at the back here, which makes it a little bit awkward. You sort of got to juggle everything in place, make sure everything's aligned correctly. And I'm just going to push that drill bit through the slot just to mark a center. So you probably can't see it, but I can. So with my caliper I can scribe that mark. And I'm going to find exactly the half the width of that part, get my center, and offset either side. So we've got 50.8. So I've got my two centers, so I'll center punch that drill and tap. You don't need to see that, saw it on the other part. So I've just taken one of these castings off and I'll demonstrate the process I go through for polishing these, and all the rest are the same. But I chose this one because it's got a little bit of defect on the casting. This is where some of the sand broke away in the mold. It's just left a bit of like a lumpy edge instead of a nice sharp clean edge like that side there. So what I've done is I've mounted the casting on a block of wood here just to make it easier to handle. I'll put this in the vise and I'm going to file away that damage there, or that defect, with a warding file. Now this one's got a safe edge ground on it, so there's no teeth on that edge of the file, so I can get in to that corner there and work on that area to file away most of the material. Okay, getting close there. I can't really see what I'm doing with the camera in the way, so I'm going to work on that a bit more and get that really cleaned up. And we're going to remove this sort of like a flash line down the center of the casting there. This is actually the worst one that I made. All of the others are very clean in that corner, so I thought I'd choose this one just to show you how that process works. Okay, let's go over the Scotch-Brite wheel. That's about as good as I'll get that with the Scotch-Brite. There are some areas that you can't get into because of the rounded corner on the wheel, but that's removed the bulk of the texture from that. So we're going to do some Dremel action now. Okay, the goal here is to get right into this corner and try and remove that texture that I couldn't get with the Scotch-Brite wheel. So I've got one of these sanding drums on a Dremel, and I've left the end of the drum protruding just slightly, and that allows me to get in really close. So I'll just do this edge. They're all the same, but I'll just show you how that works. Alright, so that's sort of taken care of that surface, but I still need to get in and around here. So I'm going to do that the same way. Okay, I spent about another 5-10 minutes working on that, and I've gotten rid of all of the texture out of the corners and the edges. So now we're going to swap over to using a Cratex grinding wheel. Now you can buy Cratex in kits like this, and they come with all different shaped points and different grades. You also get the mandrel to go with it. I believe they're hideously expensive. This set was actually given to me many years ago by a relative, but made in Mexico, which is really surprising. So I've got like a wheel mounted on a mandrel there. just using fairly low speed. And I find it easier to just grip this close to your body and just work it around like that. Okay, again, I need to do a lot more work on that, but it gives you an idea of what sort of finish you can get with the Cratex. And when I've done this on the curved sections, I'll do the flats on the belt sander with a very fine belt, and then we're going to go to the buffing machine with a sort of a stitched mop and a fairly aggressive buffing paste, and we'll get this looking pretty. Then I'll just go do 2 more. I've already done 1, but yeah, we'll get them all done. And then I'll assemble the light to this point so you can see how it looks. I've just got a standard 200mm grinder here with a tapered spindle on it. And I'm using 2 different types of polishing mops. So this is a stitched mop, so it's fairly hard, fairly stiff. And this one is going to be used for the coarse abrasive. Here's our part, and directly underneath this mop I've got a piece of rubber on the floor. Now the danger here is that when you're trying to buff this and manipulate it, if you catch it, it'll rip it out of your hands, throw it on the floor. This being brass, if it hits the concrete, it's going to damage it really badly. So I'm hoping that that bit of rubber mat will protect this part if I lose it. So I'm going to start with this one, and I'm using a fairly coarse polishing wax. Now this is normally used with steel, but it's a fairly aggressive cut, and I want to get rid of all of the defects in that brass casting using the stuff. Now the other thing that I've never done before, but when I was talking to Chris Locke, he said that you should really rake these polishing mops to renew the surface, get rid of any grit or any dirt that might be in the surface of the mop. And this thing, which looks like an instrument of torture, is actually used to clean the mop. So let's do that. So what that will do is it just loosens up all of the fibers, it removes any, like I say, grit. So when these get stored in the workshop, you can get metal particles and everything falling in the surface of that mop there, and that will actually put scratches in the material as you're trying to polish it. So we'll do that, and you can pull out these loose bits if you need to. Now we're going to charge that with the polishing compound, and then we'll do the first aggressive polish on the brass using this mop. Okay, now I know this isn't finished. This is just a preliminary look at how you do this first stage. I can see there are still some defects in this, but you've got to remember this is a casting, and it's not like a machine part, it's not like a flat sheet metal part, so it may still have some tiny defects in it when we're done and we get it plated. But what I was trying to do there was to put a lot of pressure, especially on this flat surface here. This is the one where you're going to notice any defects and scratches. These curved surfaces, they don't tend to show it quite so much. And the process we're using here is to put enough pressure on it to actually make the metal smear. So what you're trying to do is actually get the metal surface to flow and fill in any scratches that are there. So we're going to go now to the loose mop, and we'll do the same thing but using a finer polishing compound. You can see that mop there is not stitched together, so it's quite loose, quite soft, sort of really fluffy on the surface there. And the polishing compound I'm using there is well, it's red. I think it's sometimes called Triple E, but these are an abrasive mixed in with the wax, and the friction from the surface of the wheel melts the wax and the abrasive sticks to the surface of the wheel. So there's our part. It's not like I say, it's not 100% finished, but it's looking pretty good. So let's have a look at all four of them now on the bench and see how they look. Okay, well, this is where we're at. Now, these are two of the castings that I polished previously. These still need a little bit of work on them. I'm not going to go over the top with these because one's going to be right at the top against the wall. This one underneath here, once again, it's going to be up quite high and you won't be able to get up real close to look at them anyway. But just for my own satisfaction, I want to try to get them a bit better than what I've got them now. And here's everything assembled. You can see that the light sockets are in, the light bulbs are in. You can get at the light bulbs from the back without disturbing the glass. So when this is installed permanently, there will be a 3D printed part in the back of the frame here, which is held in place with just 2 screws, which you can get out from the outside. You can lift this off the wall and you can change out the light bulbs from the back, so it's not a problem. So I think we're getting close to the electroplating stage, and that's going to be in the next video. And just before I do that, I'm going to polish and look after all of the rest of the brass work here and then get it plated immediately. The brass is very soft, but once the nickel cobalt electroplate goes on, that sort of is a lot tougher and a lot more abrasion resistant. So I've got to be careful with this until I get the electroplating done. Okay, got a couple of things to tell you before I finish up here today, and then we'll call it quits. Okay, a couple of things before I go. Now, some people had asked what happened to the Titan model aircraft engine. Now, if you didn't watch that series, there's a link up above there now. I think there's 18 episodes of that build. It was a bit of an epic. And what happened was I test ran the engine, I stripped it down, finished it, made it look pretty, and then I sent it back to California where it came from. Now, the gentleman that sent it to me, Roger Taylor, was very helpful in getting that engine included in the collection of the Joe Martin Museum of Craftsmanship. Now, initially the engine went in the foyer of the museum on temporary display, but it's now in its permanent display case inside the museum. So here's a photo of how it looks inside its glass case, and by all accounts the museum were very happy to receive it. Now, probably not so much because of my input, but because of the work done by its designer and original builder, George Ginevra. Now, here's a photo of George. He's in his late 90s now, and the engine that he's holding there is a souped up version of the Titan. Now, it has spark ignition and it's powerful enough to run a 3-bladed prop. Now, the important thing about that propeller is that it came from offcuts and scrap from the Spruce Goose. That's the massive airline that was designed and built by Howard Hughes. Now, for some reason, George was able to get hold of some of that scrap material and he laminated that wood together and made that 3-bladed prop. So I just wanted to share that with you because when I heard the story, I thought it was really, really cool. Now, the next thing is, if you're not already a subscriber to my channel, I'm going to ask you to please do that. Now, the thing is that I don't make any money out of YouTube, I don't monetize any of my videos, and I don't endorse any partnership deals or advertising with my videos either. It's just a hobby for me. But the thing is that I'm nearly at 30,000 subscribers, and also I'm nearly at 200 videos on my channel. Now, if I can click over both those milestones in the next couple of months, I've got some really cool stuff that I want to give away to my viewers. Now, some of the gear that I've got was sent to me by a company called Boring Research in Oregon, in the USA. So I've got a whole bunch of stuff that James Long sent me that I want to give away. And I've also got a tool that I made myself for the Rough Cuts 2022 video dump, I think it's called. And I want to get that as a prize. So this is mainly to reward, subscribers, but also some of the long-term subscribers that I've had right back from when I first started this gig. And I recognize the names, I see them in the comments. And I know that these people have been with me all that time. So I want to give them a chance to win something and just to reward them for sticking with what I do. So like I say, if you're not a subscriber, please do so. Click the little bell icon, you know what to do. and yeah, we can get ahead and actually start that prize giveaway, draw, whatever you like to call it. Alrighty, now this has gone on way too long. I'm sure I'm past my half-hour limit, so I'm going to wind it up here now. Join me next time. I'll do the electroplating on this light. It's going to look really pretty. So that's it. Preso. Thanks for watching. See ya.